Hey y'all. Okay, I wasn't going to record this video because a lot of the participation has dropped with the new announcement of the no harm from the superintendent, but I went and looked at my YouTube channel and I saw that your Geometry Packet 3, there was 51 views. So I am doing that for the 51 of you that did watch this video. Aubrey is asleep, so she will not make a guest appearance. I apologize that you have to just have me. I'm recording this at 10 o'clock. So this packet should be a little bit quicker. So let's just jump in and get started. The first thing is about similar triangles. Remember that the biggest thing that you need to remember with similar triangles is that they correspond. The letters correspond with the other one. Y'all hold on one second. I think my camera is dirty. Okay, that's much better. I'm sure one of my children have been like, I don't know, licking that or something. Anyways, so for similar triangles, you match up the corresponding letters. D is first, G is first, so D and G are similar, okay? So that means like what we know is that their angles are going to be similar to one another, okay? So if we look at these triangles, we could figure out what their ratio is and then compare those. Okay, set them equal to each other and solve. All right, then let me get organized. Okay, so what you would do is you would just create yourself a proportion. Sorry, y'all. So like I would say, okay, well, segment GF, okay, I'm going to connect that with FD. So this segment and this segment is going to be proportionate to the corresponding parts. So G and F are first and last. So D and F are going to be its proportionate part. Is that right? I'm dealing with this. I've messed up. Okay, just ignore what I just said. I was confusing myself. Okay, this 15 is a part of this triangle here, so that's our GF. So that would be 15. It's over this part of that triangle, which is 9x minus 13. And again, you guys, with these proportions, you can pretty much set them up however you want to. Okay, so 15 is here with this part of this triangle, so I'm going to use the same triangle, which is the 27, over this triangle's similar part, which is 90. Okay, and so then you just take that proportion and you solve using cross multiplication. Same thing with number 2, and then with number 3, what we have right here is a triangle that's been cut. And so this, if you remember this from class, we were able to just compare the parts, like 21 over 24 is going to be equal to the whole over the whole. So 2x plus 9 over 4x minus 12. And then you just cross multiply and solve. Okay, so that should be pretty easy. Sorry if I made that harder than it should have been. Okay. Proving that triangles are similar. Now remember, if they are congruent, there are 5 ways. That's what we talked about last review. If they're similar, there's only 3. Side, side, side shows that they're similar. Okay. Angle, angle shows that they're similar. And side, angle, side. So those are the ways that you can tell whether or not they are similar. Again, if you need some more help on that, look at YouTube and type in proving triangles are similar, and it will give you some tips on that, or you can ask me questions. Topic 3 is about the Pythagorean theorem and its converse. Okay, so remember that if it's the converse, that's when it's like the if-then statement, it would be flipped around. Okay, so if we look at a Pythagorean theorem, it has to be a right triangle. Pythagorean theorem only works for right triangles. Your legs are A and B. Your hypotenuse is always C. Your Pythagorean theorem is A squared plus B squared equals C squared. It only works for right triangles. Okay, now the converse says, given the triangle ABC with side lengths A, B, and C, if A squared plus B squared equals C squared. So if the legs squared equals the hypotenuse squared, then the triangle ABC is a right triangle. So it's just working back. So this is saying which side length forms a right triangle. First of all, make sure they're all triangles, and then you need to prove using the Pythagorean theorem. This you're just solving, very easy. Okay, and then on the next one, the next topic that we have, it's special right triangles. So again, we're still dealing with right triangles, but these are our special ones, which is the 45, 45, 90. And the 30, 60, 90. Those are our two different types. With these, remember that this is x square roots of 2. That's your rule for a 45, 45, 90. For this one, across from the 30 is going to be your x. Across from your right angle or the hypotenuse is 2x. Across from the 30-degree angle is x square roots of 3. Okay, and so that's your 30, 60, 90. These are your practice problems on that. On the last page of your packet, you have your trig practice. That is your sine, cosine, and tangent. And remember, so, ka, toa. Okay, so you can draw those little lines. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And these are your practice problems with that. All right, if you've got questions, let me know. I'll be happy to help you, happy to make sure that you are doing this correct. And then we will have our quiz on Friday. Okay, so keep working. You guys are doing great. I'm very proud of you.